In today's video, we will learn about the periodicity of the properties in the modern periodic table. So, the modern periodic law states that when elements are arranged in an increasing order of their atomic number, as in our modern periodic table, that are arranged in left to right manner, according to their atomic number, there is a repetition of the properties after a certain interval of the element, and the period of repetition of the properties is definite but not always same. Actually, the similarities in properties are repeated after 2, 8, 8, 18, 18, and 32 elements in the shells, right? So here the element with these electronic configuration, so after change in these electronic configuration, the properties are also getting repeated, and this phenomena of repetition of the properties after an indefinite interval is known as the periodicity of the property. So I hope periodicity is now clear. Now moving towards the causes of periodicity. What thing causes this periodicity in the properties? So we critically examine the electronic configuration of various elements. It is observed that with gradual increase in the atomic number, there occurs a repetition of the same outer valence shell electronic configuration after a certain interval of the element, right? So it is saying that if we see the electronic configuration of some element, right, from left to right or top to bottom in whatever manner, so we see there is similarity in the valence shell electrons, and this similarity in the valence shell electron causes the periodicity, right? So as a chemical property of an element mainly depends upon its valence shell electronic configuration, the property also shows a repetition. Therefore we conclude that the causes of repetition of the property is the repetition of the same valence shell electronic configuration of that element after a certain interval of the element. For example, alkali metals, right? The elements of group first are known as the alkali metal. All have one electron in the valence shell. You can see here in this table, these all are the alkali metals that belongs to group 1, right? That is lithium, sodium, potassium, rubidium, cesium, and francium. All of them has one electron in the outermost shell. That's why all of them will show the same kind of electronic configuration and also the same kind of chemical properties. And here the intervals are again 8, 8, 18, 18, and after 32 electrons, right? Thus after 8, 8, 18, 18, and 32 elements, there is a repetition of the valence shell electronic configuration. So here it is confirmed that if we talk about their atomic number, so the difference in atomic number, if it is 8, 8, 18, 18, and 32 in a repeated manner, there will be causes of same chemical properties or the periodicity properties, right? Now talking about the number of shells in a group or a period. So if we see down a group from top to bottom, the number of shell increases successively and one by one down the group. For example, the element of group 17, that is of halogen, right? Now moving ahead, here you can see the halogens that are of group 17 elements. Here the atomic number is 9, then 9 plus 8, that is 17, then increase it by 18. So this is how the periodicity occurs in a group. But here all of them has the same valence shell electron in the outermost shell, right? Now talking about across a period, that is from left to right, on moving across a particular period, the number of occupied shells remains the same. For example, in the second period, that is from lithium to neon, you can see here the period that is from lithium to neon, right? The number of shells remains the same, that is 2 shells only. Here it is also 2 shells, here it is also 2 shells. It is of 2 shells until neon, right? So this is all about this topic. I hope this topic is now clear to you. Thank you.